Hello my dear students, welcome back. In the previous video, we already learned about solar energy and energy from wind. And today our topic is energy from sea. So let's learn more about energy from sea. 2/3 of the surface of the earth is sea. Hence, ocean is a major source of energy. Sea waves, high tide, heat from the ocean, etc. are the phenomena that we can make use of while producing energy from sea. Tidal energy. Oceanic tides can be used to generate electricity. Floodgate dams are built across inlets. During high tide, water flows into the inlet and gets trapped when the gate is closed. After the tide falls outside the floodgate, the water retained by the floodgate flows back to the sea via a pipe that carries it through a power generating turbine. In India, the Gulf of Kutch provides ideal conditions for utilizing tidal energy. Tidal energy is not exploited in Kerala since the rising water due to high tide is less than a meter. Next one, ocean thermal energy. The surface of ocean is relatively hot due to solar radiations, but the temperature will be very low at the deep levels. Ocean thermal energy conversion plants produce energy, that is OTEC, making use of this difference in temperature. The temperature of the surface of ocean and the regions at 2 meter depth will vary by more than 20 Kelvin in temperature. The heat at the surface boils volatile liquids like ammonia. Using the gas obtained, turbine is rotated. The cold water at the bottom liquefies the gas again. By the continuous action of this, we get electrical energy. Though the ocean is an infinite source of energy, harassing of this energy on commercial scale is not an easy task. Geothermal energy. Though the surface of the earth has cooled down, making it habitable, the interior is still in the molten form. Magma, which is at a higher temperature, comes out of the core through its softer regions. Such places are known as hot spots. Underground water at this place receives heat energy from the hot spot and is converted into steam. This steam, which is confined to the region between rocks, is brought out by drilling pipes through the rocks. Using the steam, turbine is rotated to produce electricity. In India, geothermal energy is available in Madhya Pradesh. Geothermal power plants are operated in New Zealand and America. Next one, nuclear energy. Nuclear energy is of two types. First one, nuclear fusion. Nuclear fusion is the process in which lighter nuclei are combined to form heavier ones. In this process, the matter lost is converted into energy. The term nuclear means the process which involves nucleus, and fusion means two or more entities coming together or merging together to form one single entity. So the term nuclear fusion means fusion or combination of nuclei. You know that energy is produced in the stars and the sun in this way. This is the principle used for making a hydrogen bomb. The scientific world has not yet been able to produce energy commercially by controlled nuclear fusion. Nuclear fission. The process of nuclear fission was first discovered by German scientists Otto Hahn and Strassmann in 1939. They bombarded uranium nucleus with slow neutrons and found that uranium-235 was split into two medium weight parts with the release of enormous energy. The phenomenon of breaking a heavy nucleus into two light nuclei of almost equal masses along with the release of huge amount of energy is called nuclear fission. So nuclear fission is the process by which the nuclei of greater mass are split into lighter nuclei using neutrons. The mass of small nuclei formed is less than that of parent nucleus. It means that there is loss of matter during such a splitting. The matter that is lost is converted into energy. According to Einstein's equation, E equals mc square, even if the matter converted is very small, the energy produced will be very large. Uncontrolled fission will end in a huge explosion. This is the process that takes place in an atom bomb. The source of energy in nuclear reactors which produce electricity is nuclear fission. There are power stations to control fission reaction and produce electricity. They are known as thermal power stations. Nuclear reactor is a system that converts nuclear energy into electrical energy. Enriched uranium is the fuel used in nuclear reactors. India has developed the indigenous technology of using carbide fuel in nuclear reactors. The power station at Kalpakkam in Tamil Nadu makes use of such a reactor. Dangerous radioactive radiations and products are also found in nuclear reactions. Next topic, nuclear pollution. The pollution caused by the presence of radioactive substances and radiation in water, air and environment is known as nuclear pollution. The nuclear decomposition of polluted materials results in the dangerous pollutions. As a result of nuclear decomposition, alpha, beta and gamma radiations spread out. Density of polluting substance, the type of radiation, proximity of pollution to physical organs, etc. are the factors that determine the probability of danger. Nuclear hazards can be artificial or natural. Some examples for natural hazards are cosmic rays from outer space, radiations from radioactive materials on the earth, etc. For man-made hazards, the use of radioactive isotopes in the medical field, waste from nuclear reactors, etc. So let's see the precautions to face nuclear hazards. First one, shift out to safe places. Concrete buildings, buildings constructed using bricks, etc. Second one, strictly follow the directions from the concerned authorities. Third one, observe the symbols showing the nuclear radiations and behave accordingly. Fourth one, reduce the density of population in places likely to experience nuclear hazards. And the last one, if necessary, consume potassium iodide tablets or take food rich in iodine. This is the symbol showing warning against nuclear radiations. So students, that's for today. Thank you for watching. See you in the next video.